Now I'd like to describe the transformation of each of these equations from the parent function y is equal to x squared. So we do know that the vertex is hk, and it is important to always remember and refer back to the equation. Y is equal to a times x minus h squared plus k. The reason why that's important is because of this negative sign. Now, the negative is already in my equation, and so that means that my vertex is a positive 3, 5 for my xy coordinates. If it was negative, I would have that double negative again, and it would turn positive, as you see in the right example. And I'll explain further when we get there. So we know that this is a vertical shift up 5, excuse me. We're gonna do that over, and up 5 units, and it has a horizontal shift right 3 units. And again, because my vertex was moved from 0, 0 right to 3, 5. Well, right and up. This graph opens up because A is positive here, and hence has a minimum for its vertex. Taking a look at this, my vertex is -4, -6. And let's take a look to see why. Inside the parentheses in my vertex form equation, I have x minus h. If I substitute the value of -4, you will see that I do in fact get x plus 4, which is exactly what I had originally. So we must make sure we understand that when we see a positive within my parentheses, it is a negative, and when we see a negative, it is a positive. Hence why we translate right for x minus h and translate left for x plus h. So we're going to have a vertical shift down 6 units and left 4 units. Again, A is positive, so I'm going to have a minimum. Because it opens up. Now let's take a look at the last two. So my vertex is 1, -3. But we have something a little bit different. This -3. What that negative does, again, is a reflection. And so it opens down, and the 3 actually makes it more narrow, just like that. And I will have a maximum at this point. To handle the other criterias, I have a vertical shift down 3 units and a horizontal shift right 1 unit. My vertex for this is -1, 3, meaning I'm moving up 3 units and I'm translating left 1 unit. If you remember, any value that is between 0 and 1 experiences a vertical shrink, which means that my parabola just gets a little bit wider. Since it's positive, it will open up and resulting with a minimum. Great. If you need time to write this all down, right now is the perfect time to pause the video and get all this down. Now let's take a look at how we graph in vertex form. The first thing that I like to do is identify all the values for A, H, and K. It'll make the rest of the process easier. So here we have the value of A is 2, H, -2, K, -3. The axis of symmetry is x is equal to the H value, which in this case is -2. And my vertex again is HK, -2, -3. So let's plot those points and the axis of symmetry. -2, -3 is just about there. And my axis of symmetry is x is equal to -2. So now I want to find a point. I have my vertex and I need a few more points in order to graph my parabola. So I'm going to use the easiest number that I know, which is 0. If I substitute the value of 0 for x, I will get this. And now it's time to evaluate. Again, we have to remember the order of operations, parentheses, which is the 0 plus 2, exponents. 2 squared is 4. Multiplication and subtraction. So now I have a point 0, 5. And I'm going to put that right about there. So this is my rough sketch for this particular equation. But now we need to get the left side. We're going to use our axis of symmetry. I went 2 units to the right, so I must go 2 units to the left. And my point will be just about there. I'm going to curve this a little. And there you go. So my reflected point is at -4, 5. This happens to be a minimum at the value y is equal to -3. Let's take a look at another example. A little different this time. Again, let's identify what the values of A, H, and K are. A, -1. H is 3. K is 4. The axis of symmetry I have is x is equal to 3. And the vertex, HK, is 3, 4. So following the same process, 3, 4. It's about there. Now I need one more point. So again, I'm going to substitute 0 into my function. I have g of 0 is equal to -1 times 0 minus 3 squared plus 4 is equal to -3 squared plus 4, -9 plus 4, and I get -5. So my other point will be 0, -5, just about there. Continuing my graph until I reach the point, and I'm going to reflect that point over the axis of symmetry. Again, 3 units to the left, 3 units to the right, and here is my point at 6, 5. Sorry. Now let's continue. And we're going to pretend that went through the point. Different from the last one, this happens to have a maximum at the point, or at the value of y is equal to 4. Just a few more. And now we have the basic idea of how to identify key characteristics of a graph given a quadratic function in vertex form. So let's go ahead and see how we can match these equations to its graph. The first thing that I like to do is to identify the vertex for each function. So here the vertex is -1, -3, 1, 3. Sorry. 1, 3, and -1, -3. Now let's identify a vertex for the first equation. -1, -3. We have one there, and we actually have another one there. So we need to use our other information that we know about this value of a. And if you can recall, the negative value results in a reflection and a maximum. So this equation goes to that graph. Let's take a look at the next one. 1, 3. Again, I have 2 more that share. But I do know that this negative will give me a reflection. So it'll flip my parabola upside down. And this 1/2 will make my parabola a bit wider than normal. So this function goes to that graph. Again, let's take a look. We have this 1/3 here. So this will go here. And lastly, this 2 results in a vertical stretch, giving me a much skinnier graph than the rest. And that is it. I hope this was helpful and informative. This was a bit long. My other videos will not be as long. I needed to throw in the review since it's been a while. So good luck. Feel free to watch this video again. Thanks. Bye.